So today I'm going to try to solve a problem in a book called Elemental Programming Python. The problem is problem 5.7. It's called buy and sell a stock twice. So the problem is 5.7. Buy and sell a stock. And the question asks, write a program that computes the maximum profit that can be made by buying and selling a share at most twice. The second buy must be made on another date after the first sell. Alright, let's think about it. Let's say that given an array AR that represents like all the stock. Let's get an example. Say stock is 0, 5, 0. So how would I approach this? So the idea is we need to find I1, J1, and I2, and J2. And we know that I1 have to be less than J1. I is basically the index. So right here we have index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's also I2 has to be less than J2. And according to the question, we have to buy second stock after we sell the first stock. So that means that I2 have to be greater than J1. So how do we do this? This is tricky. So in the case that we can only buy one stock and sell one stock, we would basically find like we basically try to find the current minimum on each stage and then subtract by that stage. For this, so if we use that idea, so let's say that, let me change my marker. So in the case that we only like buy one stock and sell one stop, what we need to do is we create an table, current local, oh no, current min. So basically we look at this stage, what is the current minimum? Because the idea is we want to take that value and subtract the current minimum. So initially, current minimum is unknown. So let's represent it like infinity. And then right here, current minimum is 0. Right here, current minimum is 0. Because we have seen 0, and this is current minimum. This is a very bad example. But whatever. So it's all 0. Let's modify the input a bit. So let's do let's do 10. No. 12. Give it 2. 0. 2. 4. And 0. All right. So if this is the case, so same idea. Initially we start with an unknown current min. Later on, at this point, current min is 10. It's like before this value, the current min is 10. At this point, current min is 5. At this point, current min is 5. At this point, so basically from this point to backward, like to the previous value, 5 is the smallest. At this point, 4 is the smallest. So basically, in order to fill the smallest, we look at which one is the smallest. So this is 4. Over here, it's basically still 4. Here, 4. Here is 0. Here is 0. And then we look at current local max. So here, in order to find local max, is we take this the value that the stock price is minus the current min. So 10 minus infinity, we get like negative infinity right here. Over here, if we do like 5 minus 10, we get negative 5. 12 minus 5, we will get 7. And 20 minus 5, we would get 15. 4 minus 5, we would get negative 1. 10 minus 4 would be 6. 30 minus 4 would be 26. This is minus 4. This is 18. This is 18. So if the question was, instead of buying and selling stock twice, if it was just like selling or buying stock once, the answer would be 26. That's like our profit. But since this question asks us to figure out buy and sell stock twice. So like for this case, like right here, so our minimum at this point is 4 because we buy right here and then we sell right here, right? However, we cannot take 4 minus 0 right here because we already sold this stock at this day, so we don't have that 4. So basically we want to create an algorithm like for buy and sell stock twice. We basically create an algorithm that generates like this 2 table, and then we look at the, according to my observations, we look at the like local max. So right here we see like this 2, 18 and 26. So we know that we can buy at index we know that we can buy at index 4 and sell at index 6, and then we just like throw this part away and focus on this part. So in this part, if we forget whatever come before this, we would just have so current min of this one would be infinity, so we will get negative infinity, and right here would be 0, current min 0 as well. Get 18, get 15. Yeah, this is true for this case, but in other case, like for example, if our input was like this instead, think about, let's think about a simple case. If we have like this input, five, 4, 5, 6, 7, then 0, and then 15. So in this case, our algorithm, we are saying that we should buy right here and sell right here. So we get like 15 profits. However, if that's true, I think we can still consider this part. Yeah, I think we just so once we can see an idea right here. So it's like once we know the index for buy and sell, we can like eliminate that column, and then we care about this column. I mean, yeah, this column, and also like this column. Okay. How about this? When we have a 0 and 100. So according to our program right here, what it would do this way. So it would generate all the local means. So local mean here is infinity, 0, 0, 0, 0, 0. And local max would be, current min and local max. Current max would be, local max would be negative infinity, 90. This would be 5. This would be 90, 80. So according to the algorithms that I mentioned earlier, this would tell me to y0, so at index 0, and cell at index 5. So we cannot make another buy and sell if the first cell and the first buy and the first sell is at 0 and 5. Right here, I think the most optimized would be buy right here, then sell right here. No, buy this here and sell it here, buy it here and sell this here. Whew. This is a tough one. What else I can do? What else? Think about it. I'm not sure. I can do like brute force to create all the possible answers. So if I do brute force for this, let's see. Let's try brute force and see how it goes. Anyways, do this example. So if I try to do brute force, it's going to look like this. So if I try to do brute force, I will basically try to compute what is the profits for what is the profits if buy at this location and sell at this, 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 and then what is the profits when buy at index 1 and sell at this time, sell at this time, sell at this time, sell at this time. The reason that I don't care about the previous stock value because you have to buy first before you sell. Right, so let's generate all those lists. So if I buy an index at 0, I would get 90. So I will have profit of 90 and then 5. So basically it's everything. Okay. So if I buy at index 1, I would get 5 minus 90, is negative 85, and then would be 0. That's not good. 80 minus 90 is like negative 10. 100 minus 90 would be 10. If I buy at index 2, I'm going to have 5 minus 100, which is minus 95. And then, oh, no, skip a step. So if I buy at 5 and I sell at 90, I would get negative, no, Oh, it's not negative, it's 85. 80 minus 5 is 75. 100 minus 5 is 95. Alright, you're getting closer. If I buy at index 3, buy. So if I buy at index 3, I would get, so I would lose money. It's 10, I lose more money over here. No, I earn $10. So if I buy at index 4, I would get 80, so I would earn 20. If I buy at 5, I cannot sell at all. So, what can I do with all this value? So, in the case that we have to only buy one and sell one stock, we would just take this, return it. But in this case, we want to figure out when to buy and to sell twice. I think it feels helpful if I draw a table represent that. So one, two, three, four, five. One, two, three, four, five. So in the case that I buy at index 0 and I sell at index 1, I will gain 95, 90, 80, and 100. So if I buy at index 1, I cannot sell at index 1, I have to sell at index 2, which is 85, 0, minus 10. So you get the idea, right? Buy at index 2, cannot sell at index 2, can only sell at index 3. So that is 85, 75, 95, same right here, 10, 10, and 20. Okay, so what can I do with this table? Does it give me any hint on how to solve this problem?
So this is kind of brute force, but we can brute force more than that, like on top of that. So I cannot. So in the case that I sell at 1, I cannot buy at 1. In the case that I sell at 2,
Oh, okay, so first, and then after that, we can recognize where is the maximum value in each stage.
so this would be 100, and this would be 10, this would be 95, and 20. So if we sell at this point, we have so if we sell at 5, we cannot sell or buy the second stop in between the buy time and the sell time. Yeah, we can do brute force as well right here. So 90, for 90, we can do a combination of 90. So buy at 0, you can sell at 1. So since you sell at 1, you cannot buy again at 1. So you can put like this. So you could buy at 2, so you go either plus 85.
How I can,
Yeah, on 9. So basically 90, and then 95.
it's tricky. All right, I guess I'm going to console with the hint and solution in the textbook and try to work on it a little bit more.